Okay, Knobs, we're going to try to work a couple chemistry problems here. You want to try to remember some of your high school chemistry, but this is the first place. This is in Ms. Green's PowerPoint. This is the first thing I see where she's telling you to commit to memory. 1 cubic centimeter equals 1 milliliter. I like this little box, this little cube here. That's 1 cubic centimeter, and this cube would be one centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10 high, 10 wide, and 10 deep. So that would be 10 times 10 times 10 is 1,000 cubic centimeters, right? 10 centimeters by 10 centimeters by 10 centimeters equals 10 to the 3 cubic centimeters. So it's 10 cubed and centimeters cubed. Well, here you see a cubic centimeter equals a milliliter, so that's going to equal 10 to the 3 milliliters, and of course that equals 1 liter. Okay, so this is just an easy way to remember that. That also gives you a little tie into mass too, because 1 milliliter then has a mass of 1 gram. If you have 1,000, so then 1 liter equals 1,000 milliliters equals 1,000 grams. That's a 3,000 grams equals 1 kilogram. But anyway, that's just a nice little thing to remember and keep in your mind. It'll help you. It might help you when you're trying to pull these units out of out of your memory. Okay, so this I noticed she also, this is the first thing, this red is hers. She's telling you, you need to know this, so you need to have this. But right here, what I try to tell people is, you're right here. You're at a deci base unit. Let's just, this would apply. I messed up there. Hold on. This would apply to any unit, so we'll just say base unit, okay, which would be a meter, a gram, whatever, right? Base unit. But if you look right here, in between here, what you have is one base unit then is going to equal 10 to the 0. Okay, so if you're going to make, if you're going to increase the number of base units, and this is the prefix, then this exponent's going to increase as you make it larger. If you're going to make it smaller than the base unit, you're going to divide it by factors of 10, then this exponent gets smaller. Okay. Anyway, it's just a thought there for you to look at. So we go here. The next thing in here is she's trying to teach you here how to remember these prefixes. But I don't know. I think it's just as easy just to memorize them. I mean, a kilogram you should remember from lifting weights. You know, I don't know how you remember this other than you just memorize them. But these are divisions. These are smaller than the base unit. Deci's a tenth, centi's a hundredth. That's pretty easy. Milli, I mean, it's so common nowadays, but you just need to remember it. Micro's a millionth, and nano is a billionth. The only one that's hard to remember, the only one that's hard, the symbol is hard to remember is micro. This is a millionth, and that's the Greek letter there. Okay, and that's 10 to the negative sixth, which equals 1 over 10 to the sixth, which equals 1 over a million. That's what that is. Okay? So here she's talking about, just trying to explain these units to you again. I don't know whether this is useful to you or not. I think this line, this black line here, is supposed to be here. I think she's trying to show you that 1 kilometer equals 1,000 meters, and the way you would normally use that in a conversion factor is as a fraction. See, this is an equality, so you can put this over this or this over this and it still equals 1. And that's the whole basis you do here on these unit conversions, okay? And that's what she's saying here, equal. These are equalities, but we're expressing them as fractions and using them as conversion factors. Okay? A conversion factor are in the form of a fraction containing a numerator and a denominator, and they are equal. The numerator is equal to the denominator, equal in different units. Okay? You know, like 1 inch is 2.54 centimeters. Different units. So it allows you, when you multiply by the fraction, it allows you to change the unit. Let's see what she's got here. Unit conversions. So, and she's talking about here by putting this 1 by the bigger unit. This is when we're talking about metric conversions. That's what she means. That's what she's talking about here with the factors of 10. So you put the biggest one like 1. If you're talking about making conversions between kilometers and say meters or kilograms and grams, you'd say 1 kilogram, and then it's equal to 1,000 grams. 1 kilometer is 1,000 meters. You know, 1 gram is 1,000,000,000 nanograms, and so on and so forth. We're going to work some problems here in a second. So here she's got, I guess this is a megagram, and that is 10 to the 6 grams. So here she's saying 10 to the 6 grams, and where is it back here? 10 to the 6 grams is equal to 1 megagram. So you got to remember that what we're saying here is that, you know, this is the idea. 1 megagram is equal to, what do I do here? What do I do? Yeah, here. 1 megagram is equal to 10 to the 6 grams, and 10 to the 6 grams is equal to 1 megagram. That's all. But the way we use it when we're converting is as a fraction. Same thing here. Centigram, 100 centigrams is equal to 1 gram. 1 gram is equal to 100 centigrams. 1 gram is equal to a billion nanograms, and a billion nanograms is equal to 1 gram. Okay, so we look at these problems here, and so we're going to convert 750 7,450 milligrams to 1 gram. So what I say is you always, you know, if you know this right away, which you should, come on, you know that 1 milligram, I'm sorry, 1,000 milligrams, 1,000 milligrams is equal to 1 gram, and 1 gram is equal to 1,000 milligrams. So you can use this fraction either way, with either one of these in the numerator and either one in the denominator. Well, what you do then is you take the unit that you're given, okay, and you're going to multiply that, and I'm going to use this system you're going to use later when you're doing the stoichiometry, and you're going to multiply this in such a way that you're going to end up in what you want. You want grams as your answer, so you're going to put grams here. Now this dictates how you're going to set up your fraction. So your fraction is going to be set up like this, with grams over milligrams, and here are your factors here. So you've got 10 to the 3 milligrams per gram. Okay, so now you plug in your 7450, and you divide 7450 by 1,000, and that's going to give you 7.45. The milligrams cancel. Okay. If you want to look at it like this, you can say, okay, if we multiply across, let's multiply on across it. and we say, okay, 7450 milligrams times 1 gram is going to equal 7450 milligram gram over 10 to the 3 milligram. If that's easy for you to see it that way, now you can see that the milligrams cancel. Now you do your division, you're just going to move this back 3 places. You move that back 3 decimal places. So that equals 7.45 grams. Here, you're going to go micrograms. Remember, that's a millionth, and this is seconds. Microseconds to killiseconds. Okay? And so what you have to do then is you have to, see if we can go down here, is you have to say, okay, now which one's bigger? I go back to the base units. What I would do is go back to the base unit, and I would convert it to seconds. That's your base unit, and then go from seconds to kiloseconds. Okay, so I know that 10 to the 6 microseconds equals 1 second. So in this case, I'm going to say 8.3 times 10 to the 3 kiloseconds, and I'm going to multiply this by seconds per, sorry, I screwed up there. It's 8.3 times 10 to the 12 microseconds. And we know that there's 10 to the 6 microseconds per second. So we come across here, and so when you divide, this is the same thing as saying 1 times 10 to the 6. So we come across here, and this is going to be 8.3 divided by 1 is still 8.3, and then when you divide numbers to an exponent, you just subtract. So this is going to be times 10 to the 12 minus 6, which equals 8.3 times 10 to the 6 seconds, because microseconds canceled. Okay, so now you got another conversion factor. You know that there's 10 to the 3 kiloseconds. I'm sorry. It's 10 to the 3 seconds per kilosecond. So you're going to multiply this like this. You're going to put, you want to end up in kiloseconds. Okay, so you're going to put kiloseconds here. 1 kilosecond times 10 to the 3 seconds. And now your seconds will cancel. And again, this will be 8.3 divided by, this is the same thing as 1 times 10 to the 3. 8.3 divided by 1 is going to be 8.3, and then 10 to the 6 minus 3, you subtract exponents, and that will give you, that equals 8.3 times 10 to the 3 kiloseconds, which is 8,300 kiloseconds. Okie dokie, that's how you do that one. Now, this chart, she says, she's going to be given to you, so it looks like these are the conversions you're going to have to do. Some of these are English to, these are English to metric, so sometimes these just screw people up big time, but it's no different. And also, the thing to remember about these conversions is this is also, you remember in high school chemistry, this is also the way you do stoichiometry. So this chart, you don't need to worry about memorizing it, but you can plan on seeing, I would guess you can plan on seeing some problems with that, with those conversions on it. All right, so let's go back here. This one's asking us to go millimeters to feet. Okay, so let's go back and see what we have. We got a yard here, so we got an inch here to meter. That's probably the best thing to do is do this one yards to 0.914 meters. Okay, so what we're going to do then is we know that 1 yard equals 0.914 meters. Okay, and I guess it's yard like that. Okay, and then of course we know 1 meter equals 10 to the 3 millimeters, and we know that 1 yard equals 3 feet. So these should be the ones that we need to the ones that we'll need to use. So we're going to take this 876 uh, millimeters 876 millimeters, and the first thing we'll do is we'll convert it to meters. Okay, so we have 1 meter per 1,000 millimeters, so that gives us 0.876 meters. And then we have 3 feet. We want our final answer to be in feet, so here we're going to do it in 2 steps here. So we've got 3 feet. Wait a minute. No, we gotta add one more step here. Sorry, because we don't have a conversion straight from meters to feet. So we're going to have to take this meters and convert it to yards. So we're going to say 1 yard is 0.914 meters. So that'll cancel meters. Millimeters cancels here. This will cancel meters. And we divide 0.876 by 0.876 divided by 0.914, and it gives us 0.959 yards. 0.959 yards, and we know now we're going to be able to go, we know we have 3 feet. That cancels meters, and now we know we've got 3 feet per 1 yard, and so this will cancel yards, and we multiply that by 3, and that gives us 2.875 feet, and we round that to 3 significant figures because we got 3 here, and 3 significant figures is going to give us 2.88 feet. Okay. All right, let's see what we got here. So now these are the ones that these are killers here, because you got 2 units, but they're really no more difficult. So you just have to pay attention, and you just convert 1 unit at a time. You got miles per gallon, kilometer per liter. So you're gonna have to convert miles to kilometers and gallons to liters. And if we look back here on this chart, we should have those. Hopefully we've got those right there. So we got 1 mile is 1.61 kilometers. Okay. So 1 mile is 1.61 kilometers, and 1 gallon is 3.78 liters. Okay. See if I can remember that into this next page. Okay. So 1 mile equals 1.61 kilometers, and 1 gallon equals 3.78 liters. Okay? I hope it's 1.61. Anyway, so what you do then is you just ignore the fact that you've got you know, this unit, two sets of units you're going to have to cancel. Just cancel one at a time. So we're going to cancel miles to kilometers, okay? So we've got 1.61 kilometer per 1 mile, okay? Miles cancel. And we multiply 1.61 times 16. And that gives us 25.76. I'll take care of the significant figures later. 0.76 kilometers per gallon. Okay. Now we want to convert to liters, so we're going to put liters here and gallons up here, right? And we had 3.78 liters per 1 gallon. Well, the gallons are going to cancel there, okay? And so that will give us so that'll give us 25.76 kilometers per 3.78 liters. And now we just reduce the fraction, and that gives us 6.81. That gives us 6.81 kilometer per liter. We only had two significant figures there, so we have to put this in 2. So it's 6.8 kilometer per liter. But notice I only rounded once. Okay, I went all the way across, went in with my 4 significant figures, didn't finish that till I got to the end, and then rounded one time. Okay. All right. Let's see. This is millimeters per second. Whoa, what's this? I killed it. Here we go. Millimeters per second into feet per hour. All right, so we got to go back here. All right, what have we got here? Give us somewhere to get us to feet. Well, I guess we'll have to do centimeters to inch. And then what do we want? Millimeters. I forgot the question now. What did we want to do? Millimeters per second and feet per hour. Okay. So what we'll do then is we say that we've got 1 inch equals 2.54 centimeters, okay, and 2.54 centimeters is going to equal 10 times that, 25.4 millimeters. Okay, so 1 inch equals 25.4 millimeters, and then we can go to feet. Okay, we can go to feet from there, and of course we can go second. 1 hour, of course, equals 60 seconds. Okay, so we'll go here and we'll say, okay, 12.9 millimeters per second, and we'll just go ahead and do our one conversion at a time. All right, and so we know that we have 1 inch per 25.4 millimeters. Okay, and so we don't have to do each one of these subtotals, but we will just for the heck of it. So what we're going to do is divide 12.9 by 24.2. So we got 12.9 divided by 25.4, and so that's going to give us 0.5 0.5078, 0.5079 inches per second. These millimeters canceled, but this second didn't. Okay, so then we're going to go to feet. We've got 1 foot per 12 inches, right? And that's going to give us 0.5079 divided by 12. That's going to give us 0.0423 feet per second. We canceled inches, but we didn't cancel seconds, okay? So now we're going to, no, 1 hour 60 seconds times 60 minutes is 3,600 seconds. So it's 3,600 seconds per hour. So we multiply that by 3,600 and we end up with 152.36, so we round it to 152, so I think it was 152.36 feet per hour. Now the seconds canceled here, okay? We round that to 152 because we got 3 significant figures here. Feet per hour. Okay, so what you do is you take your starting unit and if you have to take multiple steps, just take multiple steps. It's no big deal. Just convert 1 unit at a time. I always do the one in the numerator first. It really doesn't make any difference which one you do first. Okay. Okie dokie. All right, so now let's take a look at, see if we can take a look at this. I don't know what happened there. See if we can take a look at this other gizmo you had here. We'll get rid of this. And she had some problems here. Again, this is the exact same type of deal here. Not anything different here. Okay? I don't know what's going on here. Okay, here we go again. Let's see. See if we can make this work here. All right, so this is boom, boom, boom. Another deal, just like we were just doing, except she's using density. Whenever you think of density, you immediately write this down. Density equals mass over volume, and therefore mass equals density multiplied by volume, and volume equals mass over density. Now she's going to give you some density problems. I've looked enough at the work she's given you on her website. I can tell you, you're going to get these density problems, so you need these 3. You need to be able to break that down immediately, okay? But what you're going to do here, you see this, you think of this, you go, oh my God, what am I doing? What am I doing? You're just using this as a conversion factor, okay? So you're starting with grams, and you're going to come over here, and you want well, you eventually want liters, but the volume unit you have is milliliters, so you're going to convert the grams you're given to milliliters, and then look what you're going to do. You're going to convert milliliters to liters, and the way you're going to do that is there. Okay, so you check your units out, and what you're going to want to multiply then is by something here. It's got grams per milliliter, and whoa, lo and behold, there it is, grams per milliliter. Okay, So you're just going to put down here is 6.30 grams per 1 milliliter. Okay, and your grams will cancel here. You'll be in milliliters here, and then milliliters will cancel there. So that's all there is to it, nothing to it. So 128 divided by 0.630. See what you get here. 128 divided by 0.630. It's going to give you 203.17 milliliters. Okay, and now you're going to multiply this by 1 liter times 1,000 milliliters. Okay, this will cancel your milliliters, and you're going to divide this by 1,000. That'll move that decimal place back 3 places, so you're going to be 203. I'll go ahead and leave that 17 in there just to show you. So that'll be 17 liters, but you're given 3 significant figures here, 3 significant figures here, so your answer is going to be in 3. It's going to be 0.203 liters. And I think we'll see that that's the answer, hopefully. I'll put a nice box around that. She'll love that. Okay. Now here, what is the mass in grams of a substance that occupies a volume? Okay. So again, density. Density equals mass over volume. It says what is the mass? Okay. Mass equals volume times density. Okay. So here, you're given a volume of 24.10 milliliters, and then boom, 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 you're solving for mass, and the density equals 12.8 grams per milliliter. So you're going to solve for mass. Mass equals volume over density. So the volume is here. Volume is here. Density is here. So you just plug them in. So it's going to equal 24.10 milliliters multiplied by the density, which is 12.8 grams per milliliter. So when you do this multiplication, these milliliters are going to cancel. Right? This is another way to look at this thing. It's just like we did up there in these conversion factors. Okay? So the milliliters cancel. So you're going to say 24.1 multiplied by 12.8, and that's going to be 308.48 milliliters. That's the only unit. I'm sorry, that's the mass. Sorry, and that's the good thing because that's what we're solving for. 308.48 grams. You're given 3 significant figures here, 4 significant figures here, so your answer has to be in 3 sig figs. And so that's going to be 308 grams. Okay? All right. Let's go to the next page. So here we're going to convert 125.6 millimeters per second to feet per hour. So that's just like the one we did before. 125.6 millimeters per second to feet per hour. And I forget our units we had there. What do we have? We had 1 inch was 25.4 millimeters, and so that's going to be 125.6 divided by 25.4. That gives us 4.94 inches. Okay, the millimeters canceled, the seconds did not. Okay, so the seconds come on over here, inches per second, and we have 1 foot per 12 inches. So we divide our 4.94 divided by 12. and that gives us 0.4121 feet, okay, per second. The inches canceled, but the seconds didn't, so they just keep on coming over here. All right, so now we're going to operate on the seconds, and we said that 1 hour equals 60 minutes, and there's 60 seconds per minute, so it's going to equal 3,600 seconds per hour. So we're going to take our 0.4121 feet per second, and we're going to multiply it by 3,600 seconds per, not per foot, per hour. So the seconds will cancel, and so we're out multiplying our 0.4121 times 3,600. And in my calculator, I didn't ever count. I had a number there, 0.412073498, and I left that in the calculator and just multiplied that by 3,600. That way I'm less likely to make a rounding error. Okay, so we end up with 1,483.46 feet per hour. Well, we've got to put this in 4 significant figures, so it's going to be 18, so it's going to be 14.83 feet per second. Okay? Alrighty, let's see if we can go down here from here. Boom, boom, boom. Don't save that. Alright, now here we're looking at which set of masses for a hydrocarbon is not consistent with the law of multiple proportions. Which set of masses for a hydrocarbon? So that's going to be 12 hydrogens here. This is 12 hydrogens. And let me see, I may have to look at this one again. That's the grams of carbon is 28, the mass of carbon is 12. So that's 2.33. That's 12 to 2.33. That's 18 to, let's see, 42 divided by 3.5. I'll have to come back and look at this one. All right, nitrogen is, here we go, nitrogen react to form nitrogen dioxide. What mass of nitrogen dioxide is produced when 36.4 grams of nitrogen react completely with 83.2 grams of oxygen? Okay, let's go here. So what we're talking about in the law of multiple proportions here in this question says that the ratio of hydrogen to carbon, if they have the same empirical formula, the same basic lowest whole number formula, then the ratio, the mass ratio of the mass of hydrogen to the mass of carbon will be the same if they have the same empirical formula, okay? So then here we're going to divide each one of these by 1. That's the mass of hydrogen. So that'll give us 12. That number won't change. 18, 24, 78, and 114. Here we're going to divide them all by 12, which is the mass of carbon. Okay, damn it, I messed that up. Divided by 1, this will be 12, 18, 24, 78, and 114. Here we're going to divide everything by 12. In this case, that'll give us 2.33. This will give us 3.5. This will give us 4.67. This will give us 15.17, and this gives us 17.92. Okay, so now we need to get this into the whole just reduce the relationship, the ratio here. Okay, so we divide each one of these here by the 2.33, and that'll give us a 1. This will give us the carbon to hydrogen ratio. This will give us a 1 to 5.14. If we divide by 3.5 here, let me say that again, we're going to divide by 2.33 is what we're going to do here. We're dividing this one by 2.33. We're going to divide this one by 3.5. That'll give us a 1 to 5.14. We divide this one by 4.67. That gives us a 1 to 5.14. And we divide this one by 15.17. That gives us a 1 to 5.14. We divide this by 17.92, and that gives us a 1 to 6.38. I think it's 6.36 is what it is. So this is the one that has a different formula. Okay, the mass ratio of all the others is the same. So number 5 is the one that's wrong. Okay, here now this problem is very simple really. It says that nitrogen and oxygen react to form nitrogen dioxide. I don't know if you know what nitrogen dioxide is or not, with nitrogen and 2 oxygens. But anyway, it says what mass of nitrogen dioxide is produced when 36.4 grams of nitrogen react completely with 83.2 grams of oxygen. Well, add them together. 36.4 grams of nitrogen plus 83.2 grams of oxygen. It's going to give you 6. What's that? 1119.6 grams. Okay. You might also want to take a look at this. If you divide the mass of nitrogen by 14.01, and if you divide the mass of oxygen by 16.00, let's see, what do you get here? You get 36.4 divided by 14.01, and you get my calculator, 36.4 divided by 14.01, and that's going to give you 2.598. Basically 2.6, and if you divide the 83.6 divided by 16, you get 5.2, approximately 5.2. And if you divide both of those by 2.6, divide them both by 2.6, what do you get? You get a 1 to 2 ratio, and that's what you have in nitrogen dioxide. That 1 is written there in the formula, and that 2 is there. Okay, I'm sure you'll get to that a little bit later. But here, what we have here is we got, again, the same, she's setting you up for the same thing here. You've got 93.6 grams, 93.6 grams of carbon plus 18.2 grams of hydrogen. And so that equals a total of 111.8 grams. Well, 93.6 carbon over the total mass, 111.18, gives you a 0.637 percentage of carbon. In other words, 63.7% of this compound is carbon. Well, if you multiply that times your total mass here, times the 314 grams of this other sample, then that's going to give you the percentage of carbon in that too, because the law of multiple proportion says that that percentage stays the same, and that comes out to 262.88. 262.88. And I'm going to have to get that phone. Hold on. And you got 3 significant figures here, 3 significant figures here, 3 significant figures here. So you got to put this in 3 sig figs, which is 263 grams. Okay, there's your answer right there. Okay. All right, let's see, what do we do here? This is your answer here, 119.6 grams here. Number 5, that's your answer there. And that should be it. Okay, if you have any other questions, give me a call. Alrighty, bye.